So here we have the software-defined radio SDR ICOM IC7300, and we're going to run a few tests as it comes from factory, and then we'll try it with the Asymod. We'll be recording here on the computer with Vegas again, and we'll be receiving on the ICOM IC7000 and monitoring our modulation here on the oscilloscope. So we'll be using the hand mic, and we have preset our carrier for 5 watts. Okay, so here we go. Let's start the recording.
Audio 1 2 3 4. Hello, audio test 1 2 3. Audio test 1 2 3 4. Hello, test. Audio 1 2 3 4 5. Audio 1 2 3 4 5. Hello, audio test 1 2 3 4. There's your 100% modulation, and we're gonna go ahead and try it on sideband now.
So we'll go ahead and change our mode here. Sideband, upper. Go here, upper.
Audio 1 2 3 4 5. Hello, audio test 1 2. Hello, audio. Audio 1 2 3 4 5. Testing 1 2 3. And here in sideband, audio 1 2 3 4 5. Test 1 2. Hello, audio. Audio 1 2 3 4 5. Testing 1 2 3 4 5. The ICOM IC7300 as it comes from factory. And now we're going to go ahead and plug in the Asymod Standalone unit and see how that works out.
Alright, so we're going to go ahead and plug in the standalone unit, which should be fairly simple, and we just simply have to connect our connectors here in the back. We have our line in connector, we have our ground connector, your PTT connector, and your signal connector, your HDMI wire for all your controls. So we'll do that, and there we have installed our Asymod Standalone unit, and we're ready to give it a test run. So we have installed a switch in the back which enables us to disable the Asymod and to enable it. At this point we're going to flip that switch and enable the Asymod, and we'll go to let's go to AM. As you can see, the Asymod comes on. We're going to go ahead and set it for a 5 watt dead key. We're going to go ahead and transmit. Let's put the carrier down before we transmit. We're going to go ahead and transmit. So we'll slowly bring up our carrier till we get a 5 watt carrier right there. And the asymmetry control is all the way down, so we should see 100% modulation. We're going to have to bring up our modulation level just a little bit up. Should be about good enough.
Audio 1 2 3 4 5. Audio 1 2 3 4 5. Audio test 1 2 1 2 3 4 5. That's your 5 watt carrier, about a 20 watt PEP. That puts us at about 100% modulation. Audio 1 2 3 4 5. Audio 1 2 3 4 5. Audio 1 2. So there you have it. 100% modulation, but there's a significant difference in the audio from using the Asymod to when the radio is stock. This audio, although we're using the hand mic, it sounds a lot more hi-fi. It sounds a lot more. It has a lot more fidelity in it. Audio 1 2 3 4 5. Audio 1 2 3 4 5. Testing 1 2. So there you have it. This is a stock mic using the Asymod 3S here with the ICOM IC7300.
And we're going to go ahead raise up the asymmetry just a little bit now. To about 230 or 3 there. 1, 2, 3, 4, 5. As you can see there, the positive swings are up to like 30 watts. Audio 1, 2, 3, 4. And our modulation here, it's audio 1, around 200% modulation now. Audio 1, 2, 3, 4, 5. Hello, audio test. 1, 2. 200% modulation now with the IC7300. And by no means this radio, the software-defined radio, would allow anything above 100% modulation to come out of it as it is from factory. So there you have it.
Here we are. We're going to run the process audio now with the RE20 and our Asymod installed. We'll start recording, and we'll transmit. You can use the PTT mouse also. So there we have our 5 watts of dead key. We'll go ahead and activate the microphone.
Audio 1, 2. Audio 1, 2, 3, 4, 5. Hello, audio. Audio 1, 2, 3, 4, 5. As you can see there, we're 20 watts there. Audio 1, 2, 3, 4, 5. As a compressed audio maintains our power more constant at our maximum. Right there, you can see we're almost at 20 watts all the time, whereas when we were using the hand mic, it would be around 10 watts, 15 watts. So you see the compression kicking in. And obviously the audio, there's a big difference in the audio using the processed audio. And we'll go ahead and raise up the asymmetry just a little bit now. Audio 1, 2, there's your 100% modulation. Audio 1, 2, 3, 4, 5. Audio 1, 2. And we're recording here on Vegas. Audio 1, 2, 3, 4, 5. We'll go ahead and bring up the asymmetry a little bit. Audio 1, 2, 3, 4, 5. There you can see now we're about 30, 40 watts. Audio 1, 2, 3, 4, 5. And over here, audio 1, 2, 3, 4, 5. Our peaks are up. Audio 1, 2, 3, 4, 5. Hello, audio test. 1, 2. Audio 1, 2, 3, 4, 5. Almost, I see peaks there of almost 275% modulation. Audio 1, 2, 3, 4, 5. Hello, audio test. 1, 2. So there you have it. Audio 1, 2, 3, 4. The ICOM IC7300 software-defined radio. Running analog modulation, hi-fi, asymmetrical modulation. Audio 1, 2, 3, 4, 5.
And here we are in sideband. Audio 1, 2, 3, 4, 5. Receiving on the IC 7000. Audio 1, 2, 3, 4, 5. Test 1, 2. We're here on sideband running the processed audio. Audio 1, 2, 3, 4, 5. Test 1, 2. Audio 1, 2, 3. Audio 1, 2, 3, 4. Hello, audio 1, 2. So there you have it, the IC7300.
So let's switch back over to AM. And now we're going to see the swing back effect that it was asked to show at an RMS reading, because this radio used to always peak backwards on the RMS reading. So we'll go ahead and transmit. Audio 1, 2, 3, 4. Audio 1, 2, 3, 4, 5. As you can see, that's 100% modulation, and we're peaking forward. Now, if we put up the asymmetry a little bit, you're going to see a lot more of that. Audio 1, 2, 3, 4, 5. Audio 1, 2, 3, 4. And that's an RMS. If we go to peak reading, audio 1, 2, 3, 4, 5. This is for those who question the possible interference that can be caused by the asymmetrical gain on the positive side of the sine wave when we're doing asymmetrical modulation, and they confuse splatter, which is when you pinch at the 0 volt line, you create other multiple frequencies other than those of the fundamental. Therefore, each additional frequency that's created due to the splatter creates its own harmonics. Before you know it, you have hundreds of different harmonics covering the whole band, every channel of the band. Well, here we're going to go ahead and transmit at 100% modulation. We're going to transmit with 5 watts. We're looking here at the spectrum, and we're looking at 10 channels. So you can see the center frequency there is channel 20, 27205, and our span is 100 kilohertz. So that's 10 channels. All right, and here we're going to see the modulation envelope. All right, let's center this line really good. Right there. So that's what we're looking at right there. That's our scope. The first 2 divisions up and down from that line is your carrier. The second 2 divisions up and down from that line is your 100% mark. The third is your 200, and your third is your 300%. And your fourth is your 300%, I'm sorry. So, here we'll go, and we'll key up the radio. And we're doing, let's go ahead and kill the SIGGEN. Had it on there. Alright, so here we have $5 watts on the bird. Let me also kill the mic. Alright, so we have the 5 watts on the bird. We have our perfect signal right there. Okay, our perfect carrier. Now we're going to go ahead and modulate the carrier. We're going to modulate it with a 1000 hertz. Now there you have, you're still within your channel. You're at 100% modulation. Okay, that's your carrier, 2 divisions. 100% is 4 divisions. If we go up to the next division up, as we raise the asymmetry, that's our 200%. And as you can see, we're still at our fundamental frequency. There's no splatter. As you can see, there's no pinching. There's no need for generation of other frequencies other than the fundamental. And as you can see on the meter, right now, we're doing 40 watts out of a 5 watt carrier. That's your 200% modulation. We'll go further and raise up the asymmetry to 300%. And we still have our perfect signal. No splatter. All the adjacent channels are nice and clean. And now we're way above 50 watts of PEP power. So there you go. For those who keep asking all the time if the asymmetrical modulation causes splatter, there's your answer.